Hello everyone, we are from Group 411B that consists Nico, Sada, Naya and Malvin, and today we will presenting our 4D frame project regarding Science Day celebration. So the concept model that we choose for our project is a lighthouse with a turbine in it. By combining a basic parallel circuit with a dynamo and a DIY fan, we managed to pull off a Western light turbine lighthouse. Thus, with the help of a dynamo that help our fan to work well and the circuit that can light up our lighthouse. Through all the hardship and knowledge, we finally finished our product successfully.
To construct our project, we used a total of 11 materials that consist of duplex as defined material, 1 Tamiya tire trim, PCB board, polyfoam, 1 voltmeter, 5 flat or 5 LED, 1 9 volt battery, magic straw, wire, 1 potentiometer, and 1 high torque printer dynamo 12 volt.
After deciding all the materials that we need to make our project, we finally made our blueprint. This is the front side, the back side, the left side, and the right side of it.
So guys, I will explain how to make the framework of Lighthouse. It's pretty simple. First, prepare for around 40 magic straw and 18 connector. Second, make a cube from 12 magic straw. Third, make a block by combining two cubes. And fourth, assemble them and it will look like the letter L. Fifth, create a prisma to use as a roof. And finally, unite them and become a lighthouse.
So for the electrical part, here's a simple step by step. So first, we cut the duplex to form a fan, and then we mark it, and then we make a hole so that we can fit the Tamiya tire rim, and then we fold the blade so that it can have an angle, and then we put a nose so we could reduce the coefficient of drag, and then we mount the engine into the frame, and then we tie the engine into the frame. And for this part, this one is the electrical circuit since there are lots of steps. So we put it into one piece of photo and finally we assemble it all together. And we try again because this experiment is trial and error. So there are lots of error and we try again and try again. So for the difficulties, the first one is we're basically working qualitatively. That is because some data require some specific tools. For instance, the generator. We don't have any tachometer to measure the RPM. And also, when we attach the fan, we cannot calculate data such as the coefficient of drag, coefficient of power, coefficient of lift, because those data require the use of wind tunnels and complex CFD. And also, most of the product doesn't include their specification. Some of the motors right here doesn't include the RPM and its current. And secondly, we're working with very limited equipment and limited experience. Sometimes when we try to solder the electrical equipment, the circuit becomes closed circuit, and then sometimes the voltmeter doesn't work, so we need to open it again, and then we put it again. And then, so this is the first product, and this is the final product. So there are lots of trials and error in our project. Next one. So for the mathematical principle, since we're working quantitatively, so we could simplify the fan into an airfoil, so like an airplane. And to generate a large coefficient of lift, there are two ways. First one is to make the airfoil into more chambered shape, or we could make it into an angle, so that the angle of attack could increase. So we know that the Bernoulli's principle is when the air is flowing slowly, the pressure will be high, and vice versa. So what we try to do is to make the blade angled a bit, but not too much because there's a trade-off between the coefficient of lift and coefficient of drag. And we use trial and error to find the perfect fit.
And on the next one, for our another mathematical principle, on our project we combine several scientific and mathematical principle, which is energy conservation for the wind electricity, Bernoulli principle for the propeller, and internal resistance. So in our circuit, the EMF is known as 9 volt, and each of the resistances is 80 ohms, and the voltmeter is 3.58 volt. So we cross-check it using the PHET simulator, and we got that our internal resistance is 22.4 ohm. And on the right side, there is our circuit for the illustration. And this is our final product. And that's it. Thank you very much for listening, and we hope that you enjoy our science project. Thank you.